So this question's about show that, and it's got a shape involving some algebra for the lengths, and it wants us to show that when we cut this bit out, that the area of the shape that's left is equal to that. So we can recognise here that if we do the area of the big rectangle, so area of large rectangle. Now show that questions really want you to be writing down what you're doing very carefully to describe it. So we've got 2x plus 6 all multiplied by x, the length times the width. So that gives us an answer when we multiply that out of 2x squared plus 6x. And the area of the shaded rectangle is equal to 3x, so it's just the length times the width, and basically then the area left, because so the area after cut out is equal to, well, it's 2x squared plus 6x minus 3x, which equals 2x squared plus 6x. We're nearly there because they told us what the area of this was. They told us it was 100. So we can now say that 2x squared plus 6x must equal 100 square centimetres, and of course they're wanting us to rearrange this to make it equal to 0, so that means we're going to subtract 100 from both sides to get this down to 0. So we end up with what they wanted, which was 2x squared plus, let's have a look, did I do this right? 6x, no, come on, silly boy. 6x take away 3x is 3x, isn't it? Okay, so that should be 3x. So therefore we end up with 2x squared plus 3x, take away 100 equals 0, which is what they wanted us to show. So that's what they mean by show that questions. Usually they're not too bad. They're literally about going through the context of what the question was. This is about area, and in doing those calculations you can show step by step how you're coming down to the conclusion that you're left with what they wanted. 2x squared plus 3x take away 100 equals 0. Okay. It then says calculate the length of the smaller rectangle. So in other words, we need to know the value of x. And it says give your correct answers to 3 significant figures. Well, we know this is a calculator paper, so this is where we're going to use the formula. So we're going to say that 2x squared plus 3x take away 100 equals 0. And at the front of the exam paper it reminds us that the general formula for a quadratic equation, which is what we've got because of the power 2 there, is ax squared plus bx plus c equals 0, and to solve that we have a little rule that says we do the negative of the b value plus or minus the square root of b squared minus 4ac all over 2a, and that gives us the two possible answers for this question, where the answer could be the same, of course, depends on the shape of the graph. But we now identify the values of the letters we're going to use. Well, the number and the coefficient in front of the x squared is the a value, so a is 2. The number coefficient in front of the x is the b value, and it's positive, so b will be positive 3. And the number at the end, the constant, is c, so that's going to be worth, we've got to be careful here, there's a minus in front of there, so it's going to be worth negative 100. Now the thing to be careful with this formula, I mean, most calculators now you can just literally type a fraction, press your fraction key and literally type in what you see here with these numbers, of course. But you have to be careful because that is a negative. This is saying take away. So be careful that you're recognising which keys to use on your calculators when you do this. So we replace the values that we've got here into this rule. So the x value, if I do the positive one first, in other words the plus bit here, so it's going to be negative the b value, so that's negative 3, plus the square root. Now as b is positive, I don't need to put a bracket around it, take away 4 times the a value, which was 2, times, now lots of calculators you have to be careful, you should put a bracket at this stage here because you're substituting a negative number in, so it's going to be negative 100. And again, be careful, that's a negative number, and it's all over twice the a number, so 2 times 2. So we get our calculator and we very carefully, now on my calculator, because I don't have a fraction key, that works neat and tidy like a lot of modern ones. You'll go to calculators, they'll last a while, guys. So we go through, we've got negative 3 at the front, plus the square root. Now I have to put a bracket on mine to make sure that all of this happens within the square root. So I've got 3 squared, take away 4 times 2 times open bracket negative 100, close bracket twice because I started a bracket at the beginning of the square root. So that press equals, and then I divide that by 2 times 2, which is 4. So that gives me an answer of 6.36. So 6, because I wanted 3 significant figures, 6.36. Now, because this plus is only going to change to a takeaway to get the second answer, I should be able to use my arrow and go back in. No, I can't on this one, so I'm going to have to go back and change it. So the other answer then comes from doing x equals negative 3 take away the square root of 3 squared minus 4 times 2 times negative 100 all over 2 times 2 equals. So we're going to go through and do that again, being careful to use the negative key where we need to. So negative 3, take away this time, square root, open a bracket, 3 squared, take away 4 times 2 times bracket negative 100, close bracket twice, equals, divide by 4 equals. So negative 7.86, so negative 7.86. Now, I've done that just to go through both possible answers, but what we should have realised straight away is if we get a negative answer here, or if we can assume we can get a negative answer here, then we could have ignored it because this is about lengths and you can't get negative lengths. So we could have recognised that this should be the answer straight away, the 6.36 for the x value, which is what the question wants, the length. You know, the length of the cutout bit. But of course we've done all of this hard work. It's worth 4 marks at this stage, so it's 2% of our life's work on mathematics at this stage for GCSE, up at the age of 16. So let's go through and actually check that this 6.36 works, because that we haven't made any silly errors. Now to check, you would 2 times the x value, 6.36 squared, plus 3 times 6.36, take away 100. And we'd expect the answer to be very close to 0. It won't be exactly 0 because we rounded the value of x, but we should get close. So let's have a look. 2 times 6.36 squared. Now, because it's positive, I didn't actually need to put the brackets. But I get in the habit of putting the brackets when I'm substituting, so that I don't make the mistake of substituting with negatives wrongly. So we've got 3 times 6.36, take away 100. And that gives us an answer of negative 0.0208, so very close to 0. So our check kind of worked. So we should be saying, great, that seems to be good. We can go ahead and do the next question. Okay then guys, so to show that question, just follow the logic of what the question is about, the context. This was about area, so just follow through ideas about area. And when you're recognising that you're solving a quadratic with a single variable with power 2 in it, make it equal to 0, and then identify from the formula that's at the front of your exam paper what the values of the coefficients of the x squared and the x are, and what the value of the constant is. Just being really careful when you use this formula that this front bit here is a negative, these two are takeaway signs, and if you're substituting a negative, then it's always best to substitute them inside brackets just in case your calculator doesn't handle negative calculations properly, which unfortunately a lot of calculators don't. That's solving a quadratic equation.